for developing modern Java EE applications. At the end of the session, we are going to hold a raffle. So make sure you get your ticket and get it put in the hat up here. And I can help you do that, or Lindsay can help you do that. And then you could win a Raspberry Pi. All right, we'll get started. Ready, Andrew? Okay. Hi, everybody. My name is Grant Shipley. I work on the OpenShift team at Red Hat, where I manage the developer evangelists on the team. Before that, I was a principal software engineer at Red Hat and wrote most of the web components that you use if you're Red Hat customers, like RHN and things of that nature. I've been at Red Hat for about 10 years. Before that, I worked at Novell on the SUSE operating system, where I helped write the installer for that. But today we're going to be talking about Java EE applications. And Java, you know, it's kind of fallen out of favor among a lot of people over the last 4 or 5 years. People looking at newer, cooler, sexier technologies like Node.js and other things like that. But, you know, what I found is that Java has made so many advancements over the years that it can do everything all these other languages can do, and you still get to maintain the runtime environment on the JVM. So what we're going to talk about is how you develop these modern type applications today that are primarily cloud-based, REST services, and a JavaScript front end or a mobile front end. The first component I want to talk about is cloud computing. Now, cloud computing is this big buzzword that is out in the industry, but what does it actually mean? There's 3 main components to cloud computing. The first one is infrastructure as a service. And this is where servers are provided for you. What's the most famous infrastructure as a service out there today? It's an Amazon EC2, right? So with Amazon EC2, you get to create all of these servers, but as a user of those services, you still have to administrate them all. You have to install the operating system, install the runtime, the application server, the database. You have to apply security errata updates. And just last week, there was a bash exploit called shell shock, right? And so if you were using an infrastructure as a service, you would have to go to all of your servers and patch for that security vulnerability. At the other end of the spectrum in cloud computing is called software as a service. What's the most popular software as a service in the world? Anyone? Gmail? I couldn't hear you over there, but probably Gmail. I think it's Gmail over something like Facebook, because everyone has a Facebook account, but everyone has 3 or 4 different Gmail accounts, right? In the enterprise, the most popular software as a service is Salesforce.com. With software as a service, everything is provided for you. The only thing you have to bring to the table is your application users and your data. So your users and your data. You don't really have control over the environment. Right in the middle is this thing called platform as a service, which is in harmony with this session, which is developing modern Java EE applications. Platform as a service sits between infrastructure as a service and software as a service, in that everything is provided for you except your application code, your users, and your data. So that means with shell shock that came out last week, if you're using a platform as a service and you have all your applications deployed out to that, you don't really have to worry about it because Red Hat patched all the systems for you with the latest update, right? And so as a developer, that's great, because we hate being system administrators and setting up and configuring our application servers and our databases. So a platform as a service can do all of that for you. And it's also a place where these 2 competing groups can actually get along, which is software developers and system administrators. And software developers are the Luke Skywalker, and the system administrators are the Darth Vaders of the world, right? Because as developers, we always want environments, and we send out requests to our sysadmins, and we eventually get them. It may take a week, it may take a month, but they have other things to worry about, like production level services. So with a platform as a service, it's a self-provisioning infrastructure that the operations team or systems administrators still have full control over, as far as the amount of resources that you can consume, but developers can self-service and provision servers as they want. So the platform as a service we're going to use today is OpenShift, which is Red Hat's open source platform as a service. There's 3 different versions. There's the open source code, which is OpenShift Origin. Red Hat actually hosts and maintains a public platform as a service as well called OpenShift Online that's free to use. And then we have OpenShift Enterprise, so you can run OpenShift in your own data center behind your own firewall to create your own private cloud. So OpenShift is extremely fast. It is free to use. Even the publicly hosted OpenShift Online, which Red Hat manages, you can create up to 3 servers. And that can be Tomcat, JBoss, Node.js, Postgres, MySQL, whatever you want. You can create up to 3 of those servers that Red Hat hosts and manages for you. And you can deploy your Java code out there. They can be production servers. You can have, web stores running on them and actually collecting revenue. We don't throttle the amount of bandwidth you can use or consume, so it's unmetered bandwidth, and it is completely free for up to 3 servers. Okay, so that's OpenShift. So let's start talking about the sample application that we're going to look at during this little mini session. I'm going to go through the different technologies that I'm going to use and introduce you to them if you're not familiar with some of these items. The first one is MongoDB. MongoDB is what's called a NoSQL database. And I'm a huge relational database fan. And so using a NoSQL database was really hard to wrap my head around. But MongoDB, it is document-oriented, meaning that you store JSON documents, which stands for JavaScript Object Notation, in the database. If you're familiar with traditional relational databases, a database in, say, Oracle is still a database in MongoDB. A table in Oracle or MySQL would be called a collection in MongoDB, and then a row in a table would be called a document in MongoDB. There is no referential integrity inside the MongoDB NoSQL database. So if you delete a record and you have relations that you've homegrown yourself, you will have orphaned records. And it was created for these Web 2.0 applications, to use a buzzword from a few years ago, because the thinking was that traditional relational databases wasn't created for the type of applications that developers are actually creating today, which is primarily web-based applications. So they created this database to be highly scalable and highly available from default. So you can do replica sets and sharding pretty easily. So I am using that. The next component that I'm going to be using is the JBoss Enterprise Application Platform. So if you are a Spring developer and you're typically deploying to Tomcat, I would suggest taking a look at JBoss as well to deploy your Spring-based applications. Spring-based applications are a first-class citizen on JBoss, and plus you get all the added benefit of running a full application server instead of just a servlet container. So I will be using JBoss in this sample application. The next piece of technology that I'm going to use is called Leaflet. Leaflet in conjunction with OpenStreetMap. What we're going to do is develop a geospatial aware application to present a map of all of the Major League Baseball stadiums in the United States. And we're going to be using all these technologies to do so. All right, so hopefully all that was not too boring. But what I'm going to do is show you the application that I wrote for this little session. Let me open up my web browser here. So this is the application that I wrote. It is a JavaScript front end. It's 100% JavaScript HTML talking to REST-based web services written in Java EE. Okay. The map is using Leaflet and OpenStreetMap. OpenStreetMap provides the tiles to present the map. So I didn't want to use Google. I wanted to, use an open source version. And so with this application, you can zoom in just like you would expect to do on a map. We want to look down here and look at these different areas. This is the Angels Stadium, and their team payroll is $152 million, and they're in the American League, Los Angeles. Should be the Dodgers. Then you can scroll around. And each time I scroll around, it's actually making a new REST call based on the bounds of the map in the browser. So it's getting the longitude and latitude from the corners and then doing a box query, if you're familiar with geospatial information, to pull back that data. So let's actually look at the code. The first thing I want to show you is the actual MongoDB database that's running on OpenShift. So I'm just going to SSH into my server. Maybe. Okay, so all I did there was SSH into my server that's running on OpenShift, and then I'm going to go into my Mongo database. And I just ran a count query in the MongoDB database to, get the number of teams. A few things about MongoDB while I'm in here is MongoDB is actually written in JavaScript, okay? The queries. So anytime you're running a MongoDB query, if you leave off the parentheses, it'll actually display the JavaScript code that's executing in the database to return the query. So if I do a find command, which you can think of as like select asterisk from teams, it'll return all of the values in a nicely formatted JSON document. I can scroll through these. And then if you want to look at the find code that's generated, you can look at what's actually happening in the database. Now, because NoSQL databases and particularly MongoDB are schemaless, there's a few gotchas, right? It'll create schema on the fly. So if I do db.teams.find, it'll return them all just like we just showed. But then if I misspell it, it returns nothing. But if I want to save something, so even though I misspelled teams to team, it'll create that collection on the fly and begin saving documents to it. And that gets you into trouble sometimes when you're coding. I spent literally a week trying to figure out why a particular user couldn't log in to an application I had written. And it's because I had a typo where I was saved his information in the user collection and everyone else in the users collection. And it was just a nightmare to figure out. All right, so that's the database MongoDB. Another interesting thing is I did create what's called a spatial index on this database. So most databases support this type of index, and that's what allows you to do queries based on longitude and latitude, and it'll figure out distance between points based on that number. So I just created a 2D spatial index on this. So then if we look at the Java code, I'm going to show you this in Eclipse running JBoss Developer Studio. I basically just have a JAX-RS service here that creates a DB connection. And the DB connection, to connect to MongoDB, I just included the Mongo client jar files in my Maven XML file. And then you set it up just like a traditional database, with a host, a port, a user, password, and a DB name. What's interesting, though, is because this is a cloud application that's deployed in the cloud, I'm not hard coding anything in here, IP addresses, anything like that. And the reason that is because they can change. For instance, if I scale up and automatically add a second server to my application, the IP address will be different. And so what OpenShift does is it provides environment variables for you to connect to, and you would put those in your code. So then I get an instance of the database, right? So let me go back to my code here. And here's the URL. It's going to handle GET requests, and the path is parks. So if I go out here and I say /parks, oh, maybe it's API v1. I forget what path I use. But anyway, this is what it maps to. I would have to look and see where the prefix is actually going. Okay, so if we look at the GET request for the /parks domain, or for the request, all I'm doing is creating an array list, and then I am running a find query to return all those results, and then I just iterate over it. It's very simple stuff, right? Everyone's done this before. And then the within query, which is what finds the bounds of the browser, runs this query. It passes in the lat1, lon1, which is latitude and longitude, and then the second one to run a query against, and then you run a box query. You put in the latitude and longitude, and then you return that. And that's just returning JSON documents. So let's look at the front end for this. You guys are going to have to squint your eyes here because I don't know what Eclipse uses for the font there. All right, so this is a single-page web application, and what we're doing is using the leaflet and OpenStreetMap mapping system. You can see here's the attribution that I print down at the bottom. See right here, powered by leaflet and OpenStreetMap. So that's what's printing that out. And then when this page loads, and when the map is either zoomed or dragged around, I call this JavaScript function getPins. So the getPins function creates a bounds variable, and map is a JavaScript variable that's part of the leaflet system. So it's the map that's on the screen. And I just say get bounds. And that's going to return to me the latitude and longitude that I'm actually interested in for this particular map. And then I build up my URL. Oh, it's WS. That's what I was looking for. So if you come over here and go to WS/parks, that's the REST service that's returning the JSON document, okay? So that is what the JavaScript code is calling. It's just calling the within REST service that we showed to pass in the latitude and longitude. And that's going to return a JSON document. And so then I use the get method to make that call. And then I pass in a function that it's going to call when that returns. So you can think of it as a callback, right? And so when this returns, it's going to call this callback, which is pin the map. And in the pin the map, I just remove the current layer from the map, which is the actual annotations. And then I create a new marker array. A marker is those little pins that you saw on the map. And I populate it with just HTML from the JSON document. So, you know, that's what these little markers are, these things. And so when you click it, this little pop-up is what's actually this HTML code. You guys don't want to look at my music collection. That icon looks too similar to Eclipse. Those little markers are what I'm creating here. And I just call it pop-up information, put the park name, the team payroll, the league, okay? So that's the application. Let's make a quick change so you can see how deployment actually works in a cloud-based environment. Okay, so I'm just going to change this index page, and I'm going to change the title of the page. Instead of MLB stadiums, I'm going to say at JavaOne. I'm going to save this, and then I'm going to push it up to my cloud-based servers. I can either do OpenShift publish or team commit. So I'm going to commit this code, and I'm going to say commit and push. And what's actually happening is it's committing that change that I made to my local Git repository that I have running on my local machine. And then it's going to push the change up to my remote Git repository that's running on my OpenShift server. When that happens, OpenShift is going to notice that this is a Maven-based project because of the pom.xml file, and it's going to remotely build this project on the Amazon EC2 servers that OpenShift is running on, and then it's going to deploy the war file and ear file out. And so all of that's done. You can see the output of the Maven build. Did it success? Yep, it was a success. So then we can come back over to our live running application, hit refresh, and we just pushed a code change out to our production servers. So how long does it actually take to create one of these servers? So let's just create one real quick. Let me Control-C this. I'll exit. And so I'm going to create a new application server. And to do that, I'm going to say RHC app create. I'm going to call it JavaOne. And let's do Tomcat. Since we just did JBoss, we'll do Tomcat 7. So when I hit enter there, what's happening is it's connecting out to OpenShift and saying, hey, OpenShift, this developer wants to create a new server. And that server needs to be running Tomcat 7 in this case. So it's going out to OpenShift. It's provisioning those servers for me. In this case, it's just the one. It's going to create a user for me on that server. It's going to install and configure Tomcat 7. And then it's going to create a private Git repository, populate DNS out worldwide, and then my server's ready at this point. I can start pushing code. And it is available worldwide. If you want to pull up your own browser, we called it JavaOne-grant.rhcloud.com. This is the application that we just created, and the server's already running. So then I can begin pushing my Java code, whether it's the source code, the war file, or the ear file, up to my OpenShift server. And not only that, but it's automatically scalable. So once you have your application deployed, we actually monitor the number of HTTP requests that your application gets. If you ever have more than 16 concurrent HTTP requests, we'll spin up another Java application server, clone your code over to it and deploy the code, and then front it with a load balancer, and we'll begin balancing traffic among your Java application servers that you created on OpenShift. All right, so I'm going to end it early so you guys can get your Raspberry Pi. But if you have any questions about OpenShift, I'll be around. I actually have a session tonight, a Birds of a Feather session that you can come and talk to me at. I'll be at the booth. I'm at G Shipley on Twitter. And so, yeah, that's it. So let's draw for the Raspberry Pi. Lindsay. What? Any questions? Oh, are there any questions? They don't have questions. They know everything. Hey, you guys got any questions? All right, cool. I will draw out lucky number